Hello, year 10s. Good to see you guys. Got 9 people waiting already. Look at that. You guys are great. Right, guys, just say hi on the chat and I'll run the register. How are you guys all coping? I set you guys a homework. Has everyone managed to get it done? I hope you have. As I said, just pop up on the chat. Oh, there's Natanya. Great job. Right, I'll run the register. Look at this. Oh, everyone's appearing. Look at that. Hi, Kate. Hi again. Kate made a very brief appearance in one of my A2 lessons. I've got Fatima. I've got Chiman. Yeah, there he is. Look at that. In second. I've got Kate. I haven't got Amber yet. I've got Natanya. I've got Adri. There's Zihan. Yay. I've got Adri. Hi, Adri. Good to see you. Got Ethan. Yeah, got Ethan. Missing is Amber. Look at that. Half the register done. Missing Boyang, Ryan, Oleg, and Mary is who we're missing currently. And that gives me the 8 people. It says that 7 people are watching. I'd love to know how YouTube monitors that. Whether or not if you click off the window, it then says that you're not watching. Love to know. Be really interesting. So we are just waiting on Boyang, Ryan, Oleg, and Mary. Say hi on the chat, guys, as soon as you appear. And then we're going to crack on with our lesson. So today, guys, we're continuing with moles. My lovely moles, my chemistry moles. And we're going to go through the homework for the first 10, 15 minutes. Check that you guys were able to use grams over rams to be able to calculate your moles. And then we're going to look at understanding why we're counting these particles, how that links to equations, and trying to understand why it was invented and the function it plays and why it's so important. Still missing. They're running a little bit late. They shouldn't be. It's just been break time. I'm very aware that when I've got lessons that follow on from previous ones, there are certainly times when other teachers overrun and students turn up late. I do understand that. There's Oleg. Hey, Oleg. Good to see you, dude. Good to see you. Still missing Ryan, missing Boyang, and we're missing Mary. Come on, guys. Where are you? I'm tempted to leave the register at that point, and I can mark them in when they arrive. They're going to be marked a little bit late. At 43 now, only 3 minutes into the lesson. I'll give them another minute. How's everyone coping with lockdown? Is everyone okay? I do worry about everybody. I know it's hard. Okay, I'll mark them as missing. Drama grade going down the drain. Oh, tired, boring, sleepy. Oh, I know it's tough. Oh, Kate, I'm so your drama won't be going down the drain. It won't be. Yeah, it'll be fine. How are you tired? You're at home. No, do you know what, Ethan? I can totally relate to that. I find it quite tough. I mean, in school, of course, I'm just on the go constantly, and you guys even more so. You guys just never ever seem to end in school. You're constantly, going to see one teacher or doing one activity. You guys have just got such a full-on day at school. Being at home all the time, it's very easy just to sit on the couch and just be like, ooh. I totally understand that. Totally do. Right, I'm going to mark them as missing for now. So I'm missing Mary, I'm missing Boyang and Ryan. If you guys could do me a favor and if anybody could send those 3 a message just to remind them that they're meant to be here, I'll mark them as missing for now, is what I'll do. I'll mark them as missing. Okie dokie. Also, when you're stuck in the environment for like 50 days, I know it's hard, isn't it? Y'all have to wake up early. It is tricky, isn't it? I know it's hard work. I find it harder working from home than I do in school. Partly because I'm just, I'm not setting fire to stuff. Keeps me very entertained. Right. Okay, guys. Yeah. Your homework environment becomes your school environment. I know, not ideal. I know, right? Yeah, my home environment's become my working environment. It's not nice. It's not a nice place to be. But you know what? Let's make the best of it. Let's crack on. Okay, so get rid of my keyboard. All right, folks. So I set you all the homework. Has on the chat, please. Can everyone who's in the classroom at the moment, I know I'm missing 3, can you quickly post on the classroom a thumbs up that you completed your homework? That would be great. I'll share my screen instead of you looking at my light bulb. Oh, funny. Oh, there you go. There's Bo Yang. Internet issues. No worries, Bo Yang. Don't worry about it. I'll mark you as in. Good job, Oleg. Thank you very much. Bo Yang, did you have a chance to do your homework? Thank you, Ethan, for doing it as well. Appreciate that. Give me a thumbs up, guys. Yeah, I love that. Chimonskishon. Yeah. Kate, thank you so much. That's great for having a go. Well done. Natanya, good job. It's just nice to have everyone contribute on my chat. Chimon, you need to learn how to do the little thumbs up. Come on. Give me a thumbs up. Bo Yang, up. Thumb up. Zihan, I love that you guys can't figure out how to find your thumbs up. Adri, well done. Fatima, well done. Good job. Right, let's run through it, folks, and then we can add the marks to our marks scheme. Okay, so we are counting particles. Moles is all about counting particles. So, okay, we have been given 90 grams of water. Number of moles is grams over rams. You should write that down I can't find the thumbs up, but I did it. Guys, I you know what? I'm always trying to stress to my students from the earliest point, I write down these equations every question. And I do this after 15 years of teaching A-level chemistry. Writing them down helps reinforce it. So moles is grams over rams. I have 90 grams. The question is, how much does water weigh? So water is H2O. Hydrogen is 1 on the periodic table. Remember, each element has a symbol. Yeah. And it's the top number that matters because this is the mass number and it's how heavy the particle is. So hydrogen is 1. Oxygen is 16 and 8. So we're using 16 as it's the mass number, the protons and the neutrons. It's the weight, it's the mass of the atom. So we've got hydrogen times by 2 because there's 2 of them in it. And then we're going to add it to oxygen 16 times 1. Total for water is 18. I like it. So we're doing 90 divided by 18. I'm going to get a calculator out. Yes, I know I don't need to. It's 5, but I'm still going to do it on my calculator. That's how nerdy I'm doing it just because I know that it's so easy to make a mistake. Guys, first answer is 5. Tick it if you got it right, folks. Next, I have got 20 grams of butane. I don't know how far. I don't know how far, how much you remember, guys, from year 9. In year 9, you did some organics. And 4 carbons is bute. And 2N plus 2 for the H's tells you it's an alkane. So this is butane. Number of moles is, I'm going to actually shrink my pen. Number of moles is grams over rams. So number of moles equals the grams is 20. That's easy. But now I need to work out the weight of butane. So butane is C4H10. And we have got carbon 12 times by 4 plus hydrogen 1 times by 10. I have 58, don't know, 12 times 4 plus 1 times 10 gives me 58. So I'm going to do 20 over 58, and I get a number of 20 divided by 58 gives me 0.345. Now, I've actually made a mistake. Guys, already, Mr. Duncan has already made a mistake. The reason being, if you look at the question says very specifically 3 significant figures. What that means is my first answer is wrong. My first answer should have been, I'm sorry that I'm rubbing all that out. Yeah, the first answer should have been 5.00. Yeah, moles. By the way, just to tell you, yeah, that the word, obviously you can do it, write moles entirely if you wish. Yeah, or you can just write down mole. That's the units for moles. Yeah, but you can write down moles as well if you prefer. I actually kind of switch between the two of them. But 3 sig fig is the trap there. Yeah, I'm not too fussed, by the way, about the 3 sig fig. What I'm here doing is reinforcing grams over rams. Right, next equation, number of moles is grams over rams. I have got number of moles is therefore 685 divided by, ammonia. Guys, you've got to know that guy. This one is the most important chemical in the history of mankind. Did you know that 5% of all the electrical energy that we generate on this planet goes into making that? That's how important ammonia is. The reason for that is because ammonia is used to make ammonium nitrate. Just to tell you, ammonia, this NH3, which is ammonia, it is so important because we use ammonia, we react it with nitric acid to make ammonium nitrate. And ammonium nitrate is artificial fertilizer. This is fertilizer. Now, if we didn't invent the Haber process to make that chemical, our population on our planet would be no bigger than 1 billion. The planet cannot sustain 7.5 billion people without us making artificial fertilizers. And as I said, 5% of all energy generated on our planet, of all energy goes into making that. It's that important. So, so important. So, okay, how much does it weigh? Nitrogen is 14 times by 1 plus hydrogen, which is 1 times by 3. Total is 17. So 685 divided by 17, 3 significant figures. 685 divided by 17 gives me 40.3 moles. There we go. 40.3 moles. Tick it if you got it. Next. First clever question. They've given us tons. I wonder if people have had to look that up. So a ton, just to do the little conversion, 1 ton. Now, can I just put it? There's actually 2 tons. What a nightmare. You guys don't need to know this, though. Yeah, 1 ton is equal to 1,000 kilograms, which is equal to 1 million grams. That's the conversion. So we need to do number of moles as grams over rams. So the grams is massive. So number of moles equals 102 million grams divided by, what does oxygen weigh? Well, oxygen on the periodic table is 16, but it's in a pair. Oxygen weighs 32. So over 32, and I get 102, counting them on my calculator, 1, 2, 3 zeros, 1, 2, 3 zeros, divided by 32 gives me 3 million, that says to 3 significant figures, 3,190,000. That's what it would actually be in your exam to 3 sig fig. But I will, and that's moles, mole. I will also accept 3,187,500. If you've done that, you can have it as well. I'm not, according to Google, I did something wrong. I know. So, okay, it's a bit of a nightmare, this. There are actually, annoyingly, there are 2 tons. Yeah, there's the ton versus the ton. Now, I know it's a nightmare. This is old. Yeah, this is old. We don't use it anymore. Yeah, we only use this one, which is 1,000 kilograms. I know. Sorry, Kate. If you've done the numbers, I don't mind. Yeah, you've just got to know there's 1,000 kilograms. It's a nightmare question. I apologize. Yeah, but as I said, I'm not testing you on the conversion. I'm testing you on if you can get to moles. If you've done the maths right up there with 32, I'll give you it. Yeah, I don't mind. There's a fault in the question itself. It's not your fault. Can I get half a pity mark? Oh, Kate, you can have it. You can have that mark. If you've done 32, if you've done okay, Kate, if you have done this, if you have done 102 tons, yeah, it wasn't, it was with an S, multiplied by 907185, which is the number of grams in a ton. So 102 multiplied by 907185. That's going to give, I'm going to have 92,532,870 grams over 32. If you've done that, Kate, you can have it. Absolutely fine. No problem. Next, kg is appearing. It's a trap again. Number of moles is grams over rams. Yeah, I write it down every time. 15 years of teaching, still do it. First thing you need to do is convert the kilograms to grams. That's 2,000 grams. Divided by, what's the weight of aluminium oxide? So aluminium is 27 on the periodic table, and there's 2 of them. I'm going to add that to oxygen at 16 times 3. I have no idea what aluminium oxide is. 27 times by 2 plus 16 times 3 gives me 102. So I'm going to divide 2,000 by 102. So 2,000 divided by 102, and I get a number of moles of 19.36 moles. There we go. Nice. Tick it if you got it. Next, milligrams. They're mean. Number of moles is grams over rams. So just to let you know, a milligram, 1 gram is equal to 1,000 milligrams. So to go from there to there, we've got to divide by 1,000. Oh, nasty. Nasty, 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 nasty. Right, it does make sense. This is gold. So I'm going to do 20.6 divided by 1,000. There we go, which gives me 0.0206 divided by, what does gold weigh? I have no idea. 195? 97? I don't know. It's a heavy element. I very, very, very rarely come across it. Gold, 197. There it is, guys. 197 down there. So I think I got it. Did I get it? I said 195 or 197. It was close. So 0.0206 divided by 197 gives me 1.05 times 10 to the minus 4 moles. Tiny amount. Now, guys, year 10, I'm just going to show you something. Whoops, wrong class. Atia's turned up. Hi, Atia. That's really funny. Do I have you today, Atia? Don't know. Yes, I've got you later. Just so guys let you know, I just want to show you something really cool on the calculator. So when I was in school, I hated standard form. I really didn't like it. But you guys are really lucky because there's a button on the calculator that'll make you go out of it and into it. And the button is called Eng. If you've got your calculator and your screen is here, there is a button about halfway up, all the little baby buttons here, yeah? And then you've got your main keypad here with all the numbers on it, yeah? There's a little button just here, and the button is called Eng, yeah? If you have standard form, so on my calculator, I have got 1.04568 times 10 to the minus 4. There are more numbers, but it doesn't matter. If I click Shift Eng and then Shift Eng again, it'll take me out of standard form, 0.000105. It'll take me out of standard form. And I don't get, because what I used to do back in the day, I used to hop the decimal place like this 4 times and go, oh yeah, I'm going to need to have the 3 zeros, yeah. I hated hopping. I used to make mistakes all the time. The calculator will do it for you. Shift Eng and press it multiple times. If you then, that will take you this way. If you do Shift Eng, you'll move it that way. If you just press Eng, it'll move you the other way. It's the best button in the world. I showed my A-level kids this and they nearly wet themselves. It was amazing. They were like, oh my God. Because all you deal with in maths is standard form once you get older. It's a nightmare. Anyway, Back to it. It's just nice to mention it. Yeah. I was really hoping to have some people in the classroom be like, oh my God, it's the best thing I've ever been shown in my life. Even better than chemistry. Right, let's continue with the homework. Right, guys, you can see what they've done. They've reorganized you. Number of moles equals grams over rams. Don't learn a rearrangement. Oh my God, best thing ever. IKR. I don't understand. What's IKR, Ethan? You've got to remember I'm a boomer. I have no idea what any of those things are. Why did our math teacher not tell us? I know, right? I know, right. Oh no, hang on a minute. I know. Oh, okay. Oh, that's so funny. I am a boomer. I don't know why the math teachers don't tell you. It's the best thing I have ever been shown on a calculator because it changed my world. I was like, oh my God, I'm not going to make any mistakes for standard form anymore. Woo! Best thing ever. Best thing ever. Anyway, so guys, you never ever learn a rearrangement. Now, guys, I can show you the triangle, but I hate the triangle. You guys are better than the triangle. It's looking to calculate mass. Mass is, of course, grams. Move the rams over. Times both sides by rams. Yeah, if I multiply both sides by rams, rams moves over because that one cancels. A divide and a times cancels. So our new equation becomes rams times moles gives us grams. Right. So I need to work out the rams of nitrogen. Nitrogen is 14 on the periodic table, but it's in a pair. Nitrogen weighs 28. 28 times the moles, and I've been given that, times by 4, and I get my answer. 4 times by 28, and I get a number of 112 grams, and that is to 3 significant figures. Amazing. With that, I can get standard form marks in my maths exam. I know, Ethan, honestly, I don't know why they don't show it to you. I don't know. I don't think they know about it. It baffles me. Why would you not? Crazy madness. Anyway, do they literally use the hopping thing still? Do they still teach that? Because that's madness. Madness. Anyway, next, number of moles equals grams over rams. I don't learn a rearrangement. I rearrange it each time. Yeah, bring the rams over. So rams times moles gives me grams. Right, what's the rams of nitric acid? Nitric acid is hydrogen. Hydrogen is 1 times by 1 plus nitrogen 14 times 1 plus oxygen 16 times 3. No idea what nitric acid is. Never usually work that one out. 1 plus 14 plus 16 times 3. Nitric acid is 63. Okay, so I need to do 63 multiplied by, how many moles did I get given? 0.1. 0.1, and I get, times by 0.1, and I get an answer of 6.30 grams 3 sig fig. Yeah, winner. Next, number of moles is grams over rams. I see grams, that's just what I throw out there. Yeah, they want mass. Rearrange, bring the rams over. Number of moles times by rams gives me grams. Right. So how much does potassium oxide weigh? So potassium oxide, K is 39 times 2 plus oxygen 16 times 1. No idea what potassium oxide weighs. 39 plus 39 plus 16. 94. Right. So number of moles, 0.02 times by 94, and I get times by 0.02. Got to remember the 3 sig fig, 1.88 grams, and I'm done. I like it. Next, and it is to 3 sig fig. Perfect. Oh, phosphine. Oh, that's a nasty, nasty, nasty gas. Used in chemical warfare, phosphine. Nasty stuff. Nasty, nasty stuff. Right, number of moles equals grams over rams. They want mass. That's my equation. Right, reorganize. Rams times moles gives me grams. Right, what does phosphine weigh? Phosphorus is 31 times by 1 plus hydrogen 1 times 3 equals 31 plus 3 gives me 34. Right, 34 times by 2.5 gives me times by 2.5, and I get 85. I'm going to lose on sig fig if I'm not careful, 0.0 grams. There we go. Oh, I got 88 as the rams for potassium oxide. Ooh, 39. Oh, let's check the periodic table. Maybe I got my numbers wrong. I am doing this from my head a little bit, and I shouldn't really be doing that. Sorry about that. Potassium is 39. 39 plus 39 plus 16. Did I type something in wrong? I might have. 39 plus 39 plus 16. 94. That's what I get. I get not. Oh, Fatima, I think you're wrong. 39 plus 39 plus 16. How did you get 88? What did you do with 88? 88. 39 plus 39 plus 8. 86. No, that's not even right either. They didn't use the wrong numbers. My bad. It's all right. No, Fatima, I always like students to post things like that on the chat because I'm as fallible as the next person. You know, it's just part and parcel of chemistry. I will always make mistakes as well. Next, right. Ethanol. Gotta know that, guys. That's the Friday night molecule, that, folks. There's ethanol. Okay, number of moles equals grams over rams. Right, reorganize. Rams times moles gives me grams. Right, what does ethanol weigh? It weighs 46. I know that one because I use it so often. So carbon is 12 times 2 plus hydrogen 1 times 5 plus oxygen 16 times 1 and then plus hydrogen times 1 as well. So plus another 1. 12 times 2 plus 5 plus 16 plus 1. 12 plus 12 plus 5 plus 16 plus 1 gives me 46. So it weighs 46. So I now do 46 multiplied by how many moles do I get given? 0.4. It's not very much ethanol. So times that by 0.4. So then 12 times by 0.4, and I get 18.4 grams of ethanol. Amazing. Take it if you got it. Next, oh, look at that, slaked lime. Otherwise, lime water. Calcium hydroxide is a really interesting one. If it's in aqueous, that's what actually lime water is. Isn't that cool? 10 moles of lime water. Number of moles is grams over rams. Reorganize. Rams times by moles gives me grams. How much does calcium hydroxide weigh? This is harder because there's a brackets in there. Calcium weighs 40. And there's one of them, so times by 1. Add that to oxygen, there's 2 of them. That's tricky. Oxygen is 16 times 2, plus hydrogen 1 times 2 as well, because that is also in the bracket. It's a trap. It's all a trap. 40 plus 16 times 2 plus 2 gives me 74. Weighs 74. Right, 74 multiplied by the mole number, which is 10. And I'm going to get 740 grams. Done. Nice. Right, last question. Find the formula mass. They've done a sneaky rearrangement again. Number of moles is grams. I'll zoom in on this. Number of moles is grams over rams. And it's asking me to find the formula mass. It's asking me to find rams. Technically, by the way, it's RFM. It tells me it's ionic as well, which is interesting. Yeah, so I need to rearrange this for rams. Now I have to do bid mass. Yeah, so it's bring the rams over. So I get rams times moles gives me grams. And then you have to bring the moles down. Yeah, so rams equals grams over moles. Right, now I can input my data. Right, what do I have? I've got 0.02 moles. So rams equals 0.02. They've done that deliberately, that people put in the wrong place. And grams is 1.64. Right, that's it. 1.64 divided by 0.02, and I get 82. The answer is 82. So it'd be interesting to know, I don't recognize the MR actually, but it would need to be ionic because it says it's formula mass. It's very interesting, 82. Guys, that brings us to the end of your homework. Let's go through it. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. It's out of 13. Can everyone input your data on the sheet, please? That would be lovely. Let's go to the sheet, check everyone's been filling in their data. Fill in my data. It's going to be on Google Sheets, probably. Let's go to Google Sheets. Let's see how everyone got on. Whoop, whoop. I think it was going to be... Chula data. There it is. Let's open that up. It's thinking about it. There we go. So this isn't equations. This is moles. How cool is that? Moles. But I have no idea why I just capitalized that. I definitely did not do that. Moles. And this was out of 13, right? Out of 13, guys? Hey. Oh, no, don't do anything. Oh, stupid thing. There we go. Cool. So people who've still got to fill in their data for me. Bo Yang, can you put the percentage composition one in for me? Can you fill that one in for me? Zihan, you're missing 3 homeworks. 3 of them. Can you please put in your homework data, please? And Ryan has to update his as well. I love that. Oh, Kate, don't give yourself 12 and a half. Give yourself 13. It's not fair. You got a wrong piece of data from the internet. The question itself is wrong. Like, you know that. Like, you now know that 1 ton is 1,000 kilograms. And yes, there was an old ton. How bonkers is that? Like, who has an old ton? It's like a baker's dozen being 13. It's old. A dozen is 12. Everyone knows this. You know, don't worry about it. It's nice to see data going in. Thanks, guys. I really appreciate all your help. No, different question. I thought 12 times 2 was 28. Do you know that's why I use the calculator for everything. Even if I got 1 times 2, I'll do it on the calculator. I kid you not. I don't do anything in my head, Kate. But I did the question correctly. Oh, and you've given yourself a half. That's fine. Well, that's funny. I'm trying to find it. Oh, Bo Yang, that's awesome. Well done for trying. Kate, I'm gonna knock if you didn't get the ton question wrong and you made a mistake on the calc, I'm gonna knock you down to 12. I'm gonna be super mean to you. Ha 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 ha. Hey, I'm mean, aren't I? I'm sorry. It's good to reinforce, but I did the question. Do you know what? I know that you did it correctly. I know you did. But do you know what? I always think it's good to reinforce. If you get a calc like that wrong, it's good to say, do you know what? I made a mistake. I'm not going to give myself anything for it because it will help reinforce and solidify that. Do you know what? Just do it on the calculator. Let the calculator do the maths. You guys are so, do you know what? I've never had an issue before with this. In all my previous schools, you know, the kids were great, but their maths wasn't really amazing. So what that meant was I never had an issue with kids doing questions without using their calculator. They would just automatically run everything on the calculator because they didn't trust themselves. You guys here are just amazing at maths, which means I totally understand that you'd do them in your head. But you know what? That's a great example. I think whenever I have a competition with my students where I do a test with them, I make fewer mistakes because I do everything on my calculator, everything, without fail. Love it. Is Mary here? Mary, are you there? I'd love to know if Mary was. It's really just so I know. You know, it's nice that you'd be here and you're filling in your data. I'm not sure if she is, though. I don't think so. I don't think Ryan's here either. I think Ryan and Mary are absent. Right. Okie dokie. Oh, there we go. Right. So everyone's got their data in. That's amazing. Guys, look at those results. Thank you so much. You have smashed that homework. Amber, yeah, you're missing your homework for the equations. See if you can find that data. If you can't, don't worry about it, but do the best you can. Try and track it down. Right, guys, let's crack on with our lesson today. We've got 4 learning objectives to get through, 4 learning objectives in 20 minutes. Be able to calculate moles. Everyone now is thinking, I am on that bad boy. Yes, I can do that. Moles counts particles. Just to remind you guys of this fact, I'm actually just going to go to the bottom of here. Okay. This is just one of those things I just need to kind of make sure that you guys really have in your head. So we've got today's notes, which is really moles part 2. Yeah, moles part 2. So just a nice reminder, yeah, moles counts particles. Yeah. Just to remind you of what that means. So if I have, so e.g., if I have 1 mole of water, yeah, 1 mole of water, let's quickly look at what that is. Number of moles equals grams over rams. Well, we know that I've been given 1 mole, so 1, yeah, will equal, we know what the rams is. We always have the rams. We get that from the periodic table. Mr. Duncan, yes, Ethan, how can I help? What does water weigh? Hydrogen is 1 times 2 plus 16. Everyone, you learn after a while, by the way, that water weighs 18. It's so useful. Can you show us the learning objectives? Yes, of course I can. There you go. There are your learning objectives, Ethan. If you just pause the video, you can then catch up. Yeah, just pause it and then you can make a note of them. So if I have 1 mole of water, I can now input that into here. That's the rams. It's actually rums, but you know, it's easy to say with rams. Right, what we realize is to get 1, we need 18 over 18. That will give us 1. So 18 grams of water, 1 mole of water equals 18 grams. Yeah. If I then have, let's choose someone else that everyone knows. Let's do carbon dioxide. 1 mole of CO2. 1 mole of carbon dioxide. Number of moles is grams over rams. How much does carbon dioxide weigh? Carbon dioxide, so this would be 1 mole equals, because 1 mole goes in here, and then we go grams over rams, and CO2 is carbon is 12 plus oxygen at 16 times 2, which gives us 44. To get the number 1, that goes in here. So 44, to get the number 1, we'd have to put 44 grams on top as well. So it's just really nice. So 44 grams, 18 grams of water, 1 mole. Yeah. 1 mole of carbon dioxide is 44 grams. But the amazing thing is that we have the same number of particles. Because what we're doing is recognizing that 1 particle is heavier than the other. So if I just have the grams of the rams in grams, I have 1 mole. That's a sentence and a half, isn't it? Yeah. This is a nota bene. Nota bene. 1 mole of anything is its AR/MR, remembering that that's relative molecular mass, that is rams or rums, it's relative atomic mass or relative molecular mass or relative formula mass for ionic in grams. That's really handy. It's really nice that. So oxygen, e.g., oxygen is O2. So oxygen has a relative molecular mass, it's covalent, of oxygen is 16 times 2, so that's 32, and therefore 1 mole of oxygen gas will be 32 grams. It's really handy. If I have water, we know that water now weighs hydrogen times 2 plus oxygen times 1 gives me 18. If I have 18 grams, I have 1 mole. This is really handy, really, really handy. But the point is we're counting particles. By the way, okay, I feel like I want to ask a really odd question now in my lesson. How many of you guys like chemistry? Say yes on the chat. Or by the way, I will not be offended by this. If you don't like it, you know, I totally get it. I don't even think that I liked it when I was in school. I was just good at it. I didn't really like it though. Oh, Ethan, really glad to hear that. The reason why I ask is because it's complicated. Kate, that's amazing. Love it. The reason why I ask is it depends on the topic. Yeah, fair enough. I ask this because I always want to give you the extra bits of information. Like the transition to A-level is not that much bigger. And it's just, I just want to show you those little extra bits. Some students often say to me at this point, well, hang on a minute, kind of. Adri, fair enough. It's okay. That's fair enough. Maybe I can change that. Nah. Just to let you know that at the end of the 18th century, a very oh, Mary, hi. It's nice to see you. Thanks for coming. It's just nice to tell you, a very famous scientist, the mole was invented over 250 years ago. It took 100 years for a scientist to figure out how many particles is in one mole. Just so you know, just for fun and games, yeah, 1 mole of anything, contains 6.022 times 10 to the 23, doesn't look like a 3 particles. There are billions and 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 billions of particles in 1 mole. It doesn't matter. We can treat it like the number 1. It's just so big. But the scientist that discovered this was Einstein. He didn't even get a Nobel Prize for it. He got 4.67 times 10 to the 23. It was pretty close though. And you should see the experiment he did. It was amazing. Guy was a genius. Like scary, scary, amazing. It's just amazing. But it's really cool to know that number. It's called, by the way, this number's now given a name. This is called Avogadro's number. So if I'm given 18 grams of H2O, we all now know that number of moles is grams over rams. Well, I've got 18 grams over the weight of water, which is 18. I have 1 mole in that glass of 18 grams of water. I have got, drawn in real numbers, 6. Oh, I can do it on my calculator. Do shift eng. Isn't that funny? Avogadro managed to find it. That's correct. He improved it. He got it closer to the real number. That's correct. I think I'm actually lying there, to be fair. I think they named it after him because he was someone who was counting particles. He was one of the ones who originally invented the mole, I think, rather than he improved the number. I think that's actually the case, more like it, Ethan. You can do the research on that and let me know. Why do they call it Avogadro's number? Look it up. Be really curious. So 022. I've already moved the decimal place 3 times. Just need 20 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I don't know, something like that. That's a lot of particles, guys. That's a lot of particles. It's crazy. It's really cool, though. Isn't that cool? So we can actually work out the exact number of particles, but we just call it 1. You now see why they invented them all. Makes it easy to count. So, okay. So now that we understand that we're counting particles, guys, the most important question in any science class. Yeah. Amedeo Avogadro first proposed that the volume of gas at a given pressure and temperature is proportional to the number of atoms or molecules regardless of the nature of the gas. That sounds about right. Yes. Isn't that cool? He was the first person to realize that there are actually the particles in the container could actually be counted, and he could count the particles in a gas because the volume of the gas was in the type of gas was independent of the volume. So he could just say that any gas occupied the same space, therefore they have the same number of particles. Yes! Wow. All about gases. Clever. So, guys, the first person to produce the approximate number. That's not true. That's not true. Einstein was. Look, he was the first person probably to get really close. Look it up. Einstein's mole number. I can't remember what his paper was called. Oh, God, don't do that now. I've only got 10 minutes left. Stay with me, folks. Stay with me. So, guys, the question now is, why do we care about moles? Yeah? Question. Why do I care? Why do I care about counting molecules, about moles? Well, the answer is they're furry, they're cute. Everyone should care about moles. Oh, sorry, wrong moles. Oh, such a dad joke. I'm sorry. Sorry. Why do I care about moles? The answer is we make stuff. That's the answer. And I'm now going to show you why. Like, guys, I want all of you to put down your pens for a minute. And I want you to just watch how amazing this is. So, okay, this is the answer. So, in chemistry, we like to make things. And we all know this. We do reactions and they produce products. Well, this morning I woke up, bit of a headache. And what I've decided to do is I want a glass of water. Yeah, I'm going to make myself a glass of water. But I'm going to do it the hard way. I'm going to make it chemistry speak. Yeah, I'm actually going to make it through chemistry. I want a single glass of water. Yeah, and a single glass of water contains about 330 grams of H2O. Yeah, so I'm going to make water. I'm going to make 1 cup of water, 330 grams. It's how much is in a can of Coke, just so you know. Yeah, now if I want to make water in chemistry, what elements do I now need to go to the shop and buy? I need to buy hydrogen gas, and we know that hydrogen, yeah, it ends hydrogen. It ends in En, which means the element travels in pairs. I need to go and buy oxygen, yeah, from the shop, from my chemistry shop. Yeah, and it travels in pairs because it ends in gen. Any gen or en is in a pair. Now, I'm going to take this. I'm going to take hydrogen gas. I'm going to take oxygen gas. And I'm going to react them to make my cup of water. Now, the first thing I need to do is I need to balance the equation. Now, we've been working on this together. We need to balance the equation. 2 hydrogens, 2 hydrogens. 2 oxygens, 1 oxygen. There's a problem. Double the water. Yeah? Right. I've changed somebody. Start again. 2 hydrogens, 4 hydrogens. Need to balance it. There we go. Right. I've changed something. Start again. 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. We're good. We have a balanced equation. Now, people get told that we balance equations because you can't lose things. That's not why we balance things. That equation says that 2 particles of hydrogen react with 1 particle of oxygen. Yeah, I'm going to show you those. 2 particles of hydrogen, an invisible 1 particle of oxygen, and I'm going to make 2 particles of water. Well, guys, the real question here is, I want to make 330 grams. How many particles am I actually wanting to make? How do you count particles, year 10? You count particles using moles. Moles equals grams over rams. Right, so the number of moles is, I want to make 330. I want to make 330 grams of water. How much does water weigh? It weighs 18. We get used to this. So I'm going to work out the number of particles I want to make. Divided by 18 gives me 18.3 moles. By the way, it's actually 0.3333333. I'm going to keep that number on my calculator, but I'm just going to write it to 3 sig fig. Moles. Right. Well, here's now the really clever bit. I want to make 18.3 particles. How many particles of oxygen and hydrogen do I need to buy? Well, the equation told me that to make 2 particles, I needed 1 particle of oxygen. That's half the number. So I'm going to divide that number there by 2 because the equation says that it was a 2-to-1 ratio. But it was also then a 2-to-2 here, which is the same number. So I need 18.3 particles, but I write down the word moles because moles and particles, I'm counting particles. But I need to divide that number by 2 for the oxygen. I need 9.17 moles of that guy. Right. Now, guys, I can't go to a shop. I can't go to the shop and buy moles. I need to tell them it in grams. So what I'm now going to do is convert the moles back to grams. How do I do that? Right, let's rearrange the equation. Bring the rams over. Grams is moles times rams. Right. How much does oxygen weigh? I need 9.17 particles of oxygen. Well, each oxygen is 16, but it's in a pair. Oxygen weighs 32. So I need 9.17 times by 32. Times by 32, the weight of oxygen gas. So I've kept that number on my calculator, 9.166666667 times by 32. And I get 293 grams. I'll put this up here. I'll put that right up here. I'm going to do it in red. 200, I'm going to make my pen a bit thicker. When lesson's nearly over, 293 grams. Right, how many grams of hydrogen do I need? Well, I need 18.3 particles. How much does each particle weigh? Well, hydrogen weighs 2 because each hydrogen is 1 and they're in a pair, it weighs 2. So times that by 2. 18.33333 times by 2. And I get 36.7 grams. Guys, now here's the amazing thing. 36.7 plus 90, let's call that 37. Is that right? Yeah, 37 grams. I've got a rounding error. That's what's happened. That should have been 93.7, I think. And that would have been 36.7. The point I'm trying to make is, what does that add up to? I should have done the whole number rather than rounding it. 36.7 plus 36.7 plus 9293.7. And I get, I've made the wrong number, haven't I? It should be 0.3. There we go. But anyway, the point I'm trying to make is it adds up. Guys, the mass is conserved. So I know that is a massive leap of faith. At this point, I'm going to turn back on my screen. I don't want you to write the notes of this today because I'm just very aware. Let's go to that one. We're going to be doing this next lesson. We're going to be looking at how we can use the steps and using moles, because we can count particles and we've got an equation. We can actually calculate the exact amount of everything that we need. It all comes from the chemistry. As long as you've got a balanced equation and you can count particles, I can work out exactly how much I'm going to need to make anything in this universe. I can calculate the amount of stuff I need to build you, for example. Guys, it's been a really lovely lesson. I hope you guys have a nice rest of your day. And I will see you guys all very soon for our next lesson. See you later, guys. Oh, by the way, you have no homework. Yay, no homework today. I'll see you guys next lesson. Bye, guys.